Hey everyone! Today we'll be talking about a particular kind of distance rate time word problem. Now, I use a strategy here that works for all word problems, not just these ones. So I'm going to go over that strategy before we jump into the problems themselves. The first thing you want to do when you see a word problem is identify and name your unknowns. The second thing you want to do is write down as many equations as you have unknowns, because you will need that many equations to be able to deduce what the unknowns are. The more unknowns you have, the more information you need. In other words, the more equations you need. And the final step is to solve those equations algebraically. Now, before we apply this strategy to these word problems, we're going to need to know one law that's relevant to this context, and that is that the distance that something travels is equal to the rate that something has been traveling at times the time that the thing has been traveling at that rate. For example, if you drive at a rate of 60 miles per hour for 2 hours, you will end up going 120 miles. So hopefully that law makes sense. Anyway, on to our first example. A rowing team rowed 60 miles while going with the current in the same amount of time as it took to row 10 miles going against the current. The rate of the current was 5 miles per hour. We want to find the rate of the rowing team in still water. So, step 1, we identify our unknowns. Our two unknowns in this problem are this rate of the rowing team in still water and this time that it took to row 10 miles against the current or 60 miles with the current. Let's name our first unknown R and name our second unknown T. Since we've got two unknowns, we're going to need two equations to have enough information to solve them. And so for this particular problem, you can think that we want to write one equation for each trip that the rowing team made, and that both equations are going to use this law. So going upstream, we have that the team traveled a distance of 10 miles at a rate of their still rowing rate minus the rate of the current, or 5 miles per hour, because the current is fighting them when they're going upstream, and that they rowed at this rate for t amount of time. So that is our first equation, which covered the upstream trip. Our second equation will cover the downstream trip, during which the team traveled 60 miles at a rate this time of their still rowing rate plus the current speed, because the current is now aiding them and increasing the speed that they're traveling at. And they traveled at this rate for a time of t, just as before. And that completes step 2, since we have as many equations as we have unknowns. Step 3, we're going to solve these equations algebraically. And the first thing we're going to do is we're going to distribute out the right sides of both of them. So what that leaves us with is 10 equals r times t minus 5 times t, and 60 equals to r times t minus, or plus, I'm sorry, plus 5 times t. And just so we can refer back to them later, let's call these equation 1 and equation 2. Now what we're going to do is we can subtract equation 1 from equation 2 to eliminate this RT term we've got here. And that gives us 50 equals to RT minus RT, which becomes 0, plus 5t minus negative 5t, which equals to 10t, from which a simple division by 10 on both sides gives us 5 equals to t. Plugging back in to the first equation, gives us 10 equals to 5r minus 5 times 5, which is 25, adding 25, then gives us 35 equals to 5r. And finally, one last division by 5 gives us 7 equals to r, which is exactly what we wanted to find in the first place. So the rate of the exploding team in still water is 7. Alright, let's do one more example of this. A plane has a cruising speed of 150 miles per hour when there's no wind, and at this speed, the plane flew 300 miles with the wind in the same amount of time it flew 200 miles against the wind, and we want to find the speed of the wind. That speed is going to be one of our unknowns in the first step. So circle it, call it S for speed. Our second unknown is going to be that unknown amount of time from before. So once again, we can call that T for time. And that lets us move on to step 2. Once again, we can write one equation for each trip that the plane has made. Firstly, the upwind trip, where it flew 200 miles at a rate of its cruising speed of 150 minus that wind speed, because when it's going upwind, the wind is going to be pushing against it and decreasing its speed. And it flew at that rate, or that speed, for t hours, however many t happens to be. Our downwind trip, our plane flew 300 miles so distance of 300, at a rate of its cruising speed of 150, plus the speed of the wind, s, because when flying downwind, the speed is helping the plane along. And once again, it flew that fast for t hours. And so that gives us the two equations that we need. At this point, we could solve these two equations in much the same way we solved them in the previous problem, but I'm going to solve them a different way this time, just to show that there's no one correct way to do the algebra at the end of these word problems. There's many steps that you can take to unravel these equations. What I'm going to do this time is divide equation 1 by equation 2 to try and cancel out these t's, because we don't need the t's at the very end. We only need s. And that'll give us 200 divided by 300 is equal to 150 minus s times t all over 150 plus s times t. The t's cancel out, and we're left with 150 minus s all over 150 plus s. At this point, we're going to cross multiply to get 200 times 150 plus s equals 300 times 150 minus s, and expand out our cross multiplication. So distribute, 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 and that gives us 200 times 150 plus 200 times s equals 300 times 150 minus 300 times s, which all simplifies to 30,000 plus 200s equals to 45,000 minus 200s, or 300s, my bad. And now it's just a matter of grouping all the s's on one side and dividing. So we're going to first add 300s to get 30,000 plus 500s equals 45,000, and then subtract 30,000 to get 500s equals 15,000. And now that we've successfully grouped s and non-s terms, we'll just divide out by the coefficient of s, which is 500. And that gives us s equals 30, which was the target unknown from the beginning of the problem. And that is the three-step process to solving distance, rate, time problems. Hope this video helped, and see you all next time.